In this activity, we used 3 different balls and 3 different surfaces. A ping pong ball, a billiard ball, and a golf ball. Our 3 different surfaces are a tiled floor, a wood floor, and a cemented floor. Now, we will calculate if a certain ball is elastic or inelastic on a certain surface. On this table, we are gonna be able to identify on whether the certain ball is inelastic or elastic based on how high is its bounce height on a certain surface. Here is Alan Jexter Cruz. He will explain to you how to get the starting velocity.
For starting velocity, this calculation just needs to be calculated once because the distance, acceleration, and velocities are the same for all cases. For the given, we got distance is equals to 1 meter, initial velocity is equals to 0 meter per second, acceleration due to gravity is equals to 9.81 meter per second squared, and for the formula, we got final velocity squared is equals to initial velocity squared plus 2 multiplied to acceleration then multiplied to distance. Then after substituting the given, we got 0 meter per second raised to 2 plus 2 multiplied to 9.8 meter per second squared multiplied to distance, which is 1 meter. Then we will get 19.6 meter per second. Then for the final answer, we get 4.427 meter per second. And that is the starting velocity for all cases.
Here is Cedrian Binoy. He will be explaining to you how to get the ending velocity.
So now, let me discuss about the ending velocity. We all know the velocity is the rate of change of its position with respect to a frame of reference and is a function of time. So, ending velocity is a vector quantity that measures the speed and direction of a moving body after it has reached its maximum acceleration. So what is the formula of the ending velocity? Formula of final velocity is Vf squared equals to Vi squared plus 2 times acceleration times the height. For example, the given height is 0.65 meter and the acceleration due to gravity is 9.81 meter per second squared. So if you substitute that, it will be negative 2 times 9.81 meter per second squared times 0.65 meter. So the final velocity is negative 4.47 meter per second.
Here is TJ Rogets Castro. He will be explaining to you how to get the starting momentum.
In this part, we are going to calculate the momentum of each ball before it hits the surface, starting momentum. Momentum is equals to mass times velocity, where P is momentum, M is mass, and V is the velocity right before the ball hits the surface. Like for the examples, a ping pong ball, momentum is equals to 0.0027 kilograms times 4.43 meter per second is equals to 0.0120 kilogram meter per second. Then on a billiard ball, momentum is equals to 0.085 kilograms times 4.43 ms is equals to 0.3766 kilograms meter per second. And finally, on a golf ball, momentum is equals to 0.459 kilograms times 4.43 ms is equals to 0.2033 kilograms meter per second.
Here is James Marbalusada. He will be explaining to you how to get the ending momentum.
This is how I get the ending momentum. Given the final velocity and mass of the ball, and by using the formula P is equals to mass times velocity, we can calculate the ending momentum. By substituting every value that we get from the balls to the formula, as you can see in the table, this is the result of a calculated ending momentum. Note that the same ball has different ending velocity depending on the surface we use in the experiment.
Here is Eunice Hasa. She will be explaining to you how to get the change in momentum.
Hello guys, so if you're wondering, how do we get the change in momentum? First, let us define the change in momentum. Change in minus the initial momentum, or PI. For example, we have an initial momentum of 0.0120 kg per second and a final momentum of 0.0100 kg per second. To get the change of momentum, I'm going to use the formula delta P is equals to final momentum minus initial momentum. Just get the difference between the two and you will get 0.002 kg per second. And that's how you get the change in momentum.
Why did all the balls lose momentum? All the balls lost momentum because elastic collisions don't have the same amount on which it will be perfectly the same. With the balls bounced, its energy is transferred to heat. In turn, that is internal energy, on which it will decrease the ball's momentum. Based on our experiments, which ball would be the best to use for dodgeball or for bowling? Well, the best one to use for dodgeball is the ping pong ball, for it has a weight that can't harm a person by having another person throwing it compared to the other two balls. Now, the best ball for bowling is obviously the billiard ball, because the billiard ball has less elasticity. That means it has the capability to make pins tumble or fall down. Now, which ball and surface from the experiment would be the best for playing basketball, and what about for street hockey? The ball and surface that would be the best for playing basketball is the ping pong ball on a smooth wooden surface, because this makes the ping pong ball bouncy than on a tiled surface. For street hockey, it would be the best to use the golf ball on a wooden surface, so it won't be bouncy as much as the others and lighter than the billiard ball. We want to be the least bouncy so that we can avoid having injuries.
Question number 11. All the sport associations have hired you to develop a next big sport. They want you as an engineer to develop a sport that includes some components of the sports. Describe your new sport, including what type of ball and surface will be used and why. Remember to discuss momentum and elasticity. The new game Soccer Ball, a new developed sport, includes components of other sports. The setting will be on the soccer field. Soccer Ball is a type of ball for this game. The game is composed of two teams. One team should have 6 players, 5 for the field and 1 for guarding the bowling pin. There are 2 corners, right corner and 1 player for the left corner guarding the bowling pin. There are 1 ball in the field. The first team who will put down the bowling pin gets the point. If not, putting down all the bowling pin considered as no point. The elasticity of the soccer ball derives from its mixed leather and rubber and has a spherical shape. The momentum of the ball will be same as the soccer.